Good morning, friends. This is my next lecture, and today's lecture we are going to discuss some examples or numericals. So, before going to study the examples or numericals on work done either against constant external pressure or W max, we have to know some conversion factors, isn't it? So, for that purpose, first we know the expression that is W is equal to minus P external into delta V. We know this equation. There is a work done against constant external pressures, work of expansion and work of compression is there, isn't it? Now, in this case, if pressure is expressed in atmosphere, and volume is expressed in suppose liter or dm cube, then in that case work done is always expressed in or work is always obtained in liter atmosphere. If pressure is expressed in suppose Newton per meter square and volume is suppose measured in suppose it is measured in meter cube. Yes, it is measured in meter cube. जर व्हॉल्यूम मीटर क्यूबमध्ये आणि प्रेशर जे आहे ते प्रेशर न्यूटन पर मीटर स्क्वेअरमध्ये मेजर केलं ऑर इफ प्रेशर इज एक्सप्रेस्ड इन किलो न्यूटन पर मीटर स्क्वेअर and volume is measured in suppose dm cube. In both the cases, work done is always obtained in case of joule. Work done is obtained in always joule. So remember well, during solving such examples, one you have to know the pressure and volume units, and on that whether work done is obtained liter atmosphere or joule. Work done is obtained liter atmosphere or joule. Then after that again we have to know some conversion factors, and these conversion factors are like suppose that is the if suppose 1 liter atmosphere is equal to 24.22 calories, isn't it? 24.22 calories, it is 101.325 joule. It is in joule. Or 1 joule is equal to 1 joule चं conversion calories मध्ये घेतला, it is 0.239 calories. 0.239 calories. Or again that is a 1 calorie is equal to 4.184 joule. 4.184 joule, that is converted into ergs as a 4.184 into 10 raised to 7 ergs. Or 1 joule is equal to 10 raised to 7 ergs. 1 joule is equal to 10 raised to 7 ergs. So these are some conversion factors. One again, volume unit conversion, 1 ml is equal to 1 cm cube is equal to 10 raised to minus 3 dm cube, that is equal to 10 raised to minus 3 liter, that is equal to 10 raised to minus 6 meter cube, that is equal to 10 raised to minus 6 meter cube, isn't it? Again, one pressure unit is there. हे volume unit झालं. Pressure unit जर बघितला, pressure unit, these are the energy units. Pressure unit, it is 1 atmosphere is equal to it is 760 millimeter of mercury, that is equal to 776 centimeter of mercury, that is equal to it is converted to bar. It is, I think it is 1.01325 bar. It is equal to 1.01325 into 10 raised to 5 Newton per meter square or Pascal, and just convert that into 10 raised to minus 3. If it is converted into minus 3, it becomes 10 raised to 2. So 1.01325 into 10 raised to 2, it's kilo Newton per meter square or simply kilo Pascal. So before going to study the numericals, first we have to know the conversion factors. Because until and unless exact conversion factors, we don't get the numericals or values in desired units, isn't it? And after that we are going to solve this one example, simple example. Okay. Now if you look at the example, 3 moles of an ideal gas are expanded isothermally from volume of 300 centimeter cube to 2.5 liter at 300 Kelvin temperature against a pressure of 1.9 atmosphere. Calculate the work done in liter atmosphere and जूल. त्यात वर्क डन लिटर ॲटमॉस्फिअर अँड जूल. लिटर ॲटमॉस्फिअर आणि जूलमध्ये याचं वर्क डन डिटरमाइन करायचं आहे. तर फॉर दॅट पर्पज फर्स्ट वी हॅव टू राईट द गिवन डेटा. Okay, from this example, first you have to write the given data. 3 moles of an ideal gas. 3 moles of an ideal gas. In the sense, moles of gas are given. It is n number of moles of given. There is 3 moles. Number of moles are given. There is 3 moles. Ideal gas expanded isothermally. Isn't it? Means temperature is constant. From volume 300 cm cube to 2.5 liter. गॅसचं एक्सपान्शन झालं आहे त्यावेळेस सुरुवातीचं प्रेशर किती आहे व्हॉल्यूम 300 cm क्यूब ते 2.5. सो इट इज इनिशियल इट इज फायनल. सो ॲज इट इज इनिशियल देअर फॉर V1 is equal to 300 cm cube and V2 it is 2.5 liter. 2.5 liter against temperature, yes, 300 Kelvin. 300 Kelvin. Okay, against constant pressure, there is the pressure is given, it is 1.9 atmosphere. It is 1.9 atmosphere. 1.9 atmosphere. Calculate the work done, W. We have to calculate in the 2 units. That is, first we have to calculate in the liter atmosphere work done, and second one we have to calculate the work done in joule. या 2 युनिटमध्ये आपण वर्क डन पाहिजे. So after writing the given data, first you have to try to write the formula, correct formula. So from this it is clear that this example is based on the work done against constant external pressure, that is W is equal to minus P delta V. Why? Even here 3 moles of an ideal gas are expanded isothermally up to this sentence. If the reversibly is mentioned, then we guess the example is based on the maximum work, isn't it? But just 3 moles are given and isothermal, and other data are given pressure and this one. So we are going to use the example formula, that is the W is equal to minus P external into delta V. Minus P external into delta V, isn't it? Now here work is in liter atmosphere. So when it is liter atmosphere obtained, at that time pressure must be in the atmosphere. Pressure must be atmosphere, not problem. Change in volume, delta V must be in the liter. But it is, before conversion this liter, it is 300 cm cube. So convert this 300 cm cube into liter. So how it is converted? 300 cm cube. 300 cm cube is multiplied by 10 raised to minus 3. 10 raised to minus 3. So minus 3 in the sense 3210. So it is 0.3 liter. It is 0.3 liter. Okay, म्हणजे cm क्यूबचा 0.3 लिटरमध्ये कन्वर्शन केलं. Then just substitute the values, that is W is equal to minus P external. Minus P external is 1 minus 1.9, isn't it? Atmosphere. Okay, atmosphere. Just we write the first example, that's why we write the units also. Into change in volume, that is the delta V, in the sense V2 minus V1. So minus 1.9 atmosphere into volume, that is volume in the sense V2 2.5 minus 0.3. So it comes out to be minus 1.9 atmosphere, and it is given volume is in dm cube. Volume is in dm cube, common unit, isn't it? Okay, atmosphere into 2.5 minus 0.3, it becomes 2.2. And if you solve this 1.9 and multiplied by 2.2, the answer will comes out to be 4.18. It's minus 4.18 liter atmosphere. It is the work done in first unit, liter atmosphere. Okay, just we already convert the unit, that is liter atmosphere into joule. So in that conversion we find that 1 liter atmosphere is equal to, we know that 1 liter atmosphere is equal to 101.32, it is joule. So I have to convert how much? 4.18 liter atmosphere. Therefore 4.18 liter atmosphere means how much? So if you cross multiply this, and after cross multiplying, the work obtained will be in the joule, and that work obtained in the joule we calculated, it is 423.4 minus 423.4 joule. This is the work done in joule, and this work done is in the liter atmosphere. So in this way we can solve the numericals. So here for the conversion, liter atmosphere to joule, this conversion factor is necessary. Conversion factor is necessary. Okay. Okay. So here is the second example. That is the 16 gram of oxygen expands isothermally and reversibly at 300 Kelvin till its volume is doubled, isn't it? Calculate the work done, and R is given. It is 8.314 joule per Kelvin per mole. 8.314 joule per Kelvin per mole, isn't it? Okay. For that purpose, first we have to find out whether the given example is based on W is equal to minus P delta V in W is equal to P into minus delta V, that is work done against constant external pressure, or it is based on W max. W max. So here not they are given, just calculate the work done. If they ask calculate the maximum work done, then we go through the W max equation, isn't it? W max equation. So whether the work done is maximum work done, if they ask to calculate W max, then in the problem the two or three words are very important. That is, the gas is expanded or compressed against it is expands isothermally and reversibly. So these two words are very important. Whenever these two words comes in examples or numericals, then we have to use the W max. We have to use the formula of W max. Now see here, oxygen expands isothermally and reversibly. That is the conditions to get the maximum work. That is the system must be expands isothermally and reversibly, isn't it, for to get maximum work. So the W max equation is there. So before going to start, first we have to write the given data. Isn't it? So 16 gram of oxygen, isn't it? So 16 gram of oxygen, in the sense the weight of oxygen is given, isn't it? So W, weight of oxygen is given 16 gram. Expands isothermally reversibly at 300 Kelvin. So temperature is given 300, it is 300 Kelvin, isn't it? Till its volume is doubled. म्हणजे जोपर्यंत ऑक्सिजन गॅसचं व्हॉल्यूम डबल होत नाही तोपर्यंत काय केलेलं आहे, गॅसला एक्सपांड केलेला आहे. 16 ग्रॅम ऑक्सिजनला व्हॉल्यूम डबल होणार, म्हणजे याचा अर्थ फायनल व्हॉल्यूम जे आहे दॅट इज V2 हा डबल होणार कशाच्या, इनिशियल व्हॉल्यूमच्या. सो इफ वी कन्सिडर V1 ॲज अ इनिशियल व्हॉल्यूम, अँड V2 इज द फायनल व्हॉल्यूम, हा V1 16 ग्रॅम घेतलेला ऑक्सिजन, त्याला व्हॉल्यूम V1 आहे, आणि ह्या गॅसचं एक्सपान्शन केलेलं आहे. कधीपर्यंत, जोपर्यंत हा व्हॉल्यूम डबल होत नाही, ह्याच्या डबल होत नाही, म्हणजे त्यावेळेला व्हॉल्यूम फायनल व्हॉल्यूम येणार V2 येणार, म्हणजेच V2चं व्हॉल्यूम जे आहे ते V1चे काय असणार, डबल असणार. दॅट्स वाय इफ आय कन्सिडर दॅट इज द V2, then V2 must be twice V1. So V1 itself is the initial volume. So you write here it is final volume, and V1 is the initial volume. Okay, V2 हे फायनल व्हॉल्यूम आलं आणि V1 हे काय आलं, इनिशियल व्हॉल्यूम. इट इज ट्वाइस V1, isn't it? Twice V2. Then calculate the work done. Just to calculate work done, W, and R is given. It is 8.314 joule per Kelvin per mole, isn't it? Just calculate W max. Now before going to start W max, if I write the equation W max is equal to minus 2.303 nRT log to the base 10 V2 by V1. Okay, this is the formula. Now if we check the values, number of moles, weight is given oxygen, so number of mole can be calculated. R, it is given. Temperature, it is given. V2 and V1 both are known. So before going to substitute, first we have to find the number of moles. To calculate number of moles, so how it is calculate number of moles of oxygen rather than to calculate number of moles of oxygen. So number of moles of oxygen is equal to weight of oxygen divided by molar mass of oxygen, isn't it? Weight of oxygen divided by molar mass of oxygen. So weight of oxygen is given 16 gram. What is the molar mass of oxygen? Yes, molar mass of oxygen, it is 1 oxygen. So 8 oxygen 16, isn't it? So it is atomic number. and it is mass number. Okay, atomic number and mass number. So mass numbers are added, isn't it? O2. So O plus O means 16 plus 16. O2. Oxygen gas is there. Okay, so असे 2 8 oxygen 16. So 16 16 it is 32. 16 16 32 हे atomic mass येणार. म्हणजेच त्याचं ऑक्सिजनचं मोलर मास येणार. ऑक्सिजनचं मोलर मास. So it is the 32 gram per mole. Molar mass, gram per mole, isn't it? So if you calculate it, it is 0.5 moles. It is 0.5 moles. That is the number of moles of oxygen. Number of moles of oxygen, isn't it? So if you substitute these values, then W max is equal to minus 2.303 into number of moles 0.5 into R 8.314 into temperature, yes, 300 into log to the, I will write here, log to the base 10 of, yes, V2 by V1. V2 instead of V2 twice V1 and V1 itself. So twice V1 divided by V1. So V1 cancel, and this W max is equal to minus 2.303 into 0.5 into 8.314 into 300 multiplied by log to the base 10 of 2. Okay, so log to the base 10 of 2 in the sense, yes, W max is equal to 2.303 into 0.5 into 8.314 into 300 into, yes, log to the base 10 of 2 is 0.3010. And if you solve this, the final answer comes out to be, it is 864.6 joule minus, it is work done, minus 864.6 joule, isn't it? It is a work done. So that is calculated in this equation, isn't it? So in this way, try to solve the more examples from textbook. Okay, good day.